Good day, students. Today we're going to look at the solution to number 11 on page 149 of book 1 of ma1026 booklets. And of course, this is again another word problem. So this is page 149. Okay, and it's asking us to use a system of equations again to solve this word problem. Alright, so let's read the word problem and get started. The length of a rectangle is 6 centimeters less than 3 times the width. Find the width if the perimeter is 28 centimeters. So just to make sure we understand again the rectangle, let's just sketch a little rectangle here. Alright, now we can use X and Y or L and W, whatever you feel comfortable with. So let's say we'll call the length L and the width W. Okay, now just talk about that for a second before we go back to the word problem. Now remember the perimeter, because the word perimeter is here. So let's review what perimeter of a rectangle is. The perimeter is the distance around something, and when we get perimeter, we add all sides, right? So we add up all the sides. Now in this particular one, if we're looking for the perimeter, of course we have to add all 4 sides. Will be there's the width plus another width plus a length plus a length, or often referred to 2W plus 2L, or doesn't matter the order, 2L plus 2W. So the perimeter equation is right there, twice the length plus twice the width. You just add everything, add up all sides. Okay, now in order for us to do this problem, we're going to need that idea of perimeter. Okay, let's go back and look at now the specifics of this equation or this word problem. The length, now notice we've got length called L in our diagram of a rectangle is, and of course that usually translates to equals, so we got L equals length is 6 centimeters less than 3 times the width. Now there's where people will, if they make a mistake, will make it right here. Order is important, okay, when using less than. This less than part has to become behind the variable. So 6 centimeters less, we have to move it in behind because of with subtraction, order is important. So 3 times the width we know is 3W, right? 3 times the width is 3W. And like I just said, therefore if we're doing 6 less than that, right, then we move that 6 in behind. So it's always good to put the variable first. So it's 3 times the width, subtract 6. That's 6 less than. 6 minus 3W will not work in this case, okay? So be careful. Order is important with subtraction. Put the variable first, you'll be safe. Now the second equation is the perimeter equation. We're told the perimeter is 28 centimeters. So we know the perimeter is P is 28 centimeters. Right? So 2L plus 2W is equal to 28. So there's your other equation. 2L plus 2W equals 28. So you got your diagram, you have your 2 equations. Now you just need to solve it. Now when you have a variable isolated, L here is already isolated in the top equation, right? We say isolated, which means it's by itself. If it's already isolated, then the easiest method to use is substitution. Take 3W minus 6 and substitute it into the other equation for that variable, in this case L. Alright, so what we're going to do now is look at doing exactly that. Okay, so watch this step. So I take the second equation, 2L plus 2W is 28. Now remove the L, and for that I substitute in the new L, which is 3W minus 6. So that goes in here for L. Now anytime you are substituting something in for another variable, it's safest to use brackets. So I'll use brackets. 2 times L, and L is 3W minus 6, plus W equals 28. Now you should notice that we have to use a property we've learned before called the distributive property. So we have to multiply this 2 by both items inside. So we get 6W, and 2 times minus 6 minus 12, plus 2W equals 28. Now you're right back to solving a first degree equation, which you've done several of, I'm sure, by now. So 6W and 2W we can add together. They are like terms, gives us 8W. The 12 we'll bring to the other side. To solve for W, we need to isolate the W. So we have to move 12 to the other side. That becomes positive. 8W equals 40, and then we divide each side by 8, giving us a final answer for the width to be 5, and I believe it's in meters, no, centimeters. I always put the unit of measure in. So we have the width is 5 centimeters. Now that's all it asks us to do, to find a width. So our answer is done. But if we needed to find the length, of course, that's quite easy to do as well. We would take the 5 we have for the width and put it back into one of these equations. So I'll just finish it, assuming we had to find the length as well. Be 3W minus 6. So W turns out to be 5. 3 5s are 15. 15 subtracts 6. It looks like the length is 9 centimeters. And again, put your answer in word form at the end of a word problem. So the width we found to be 5 centimeters, and the length we found to be 9 centimeters. And that's the solution to number 11 on page 149.